In this video, we're going to talk about the chain rule, and our objectives today are to find derivatives of basic functions using the chain rule, to identify inner and outer functions for composite functions, and then apply the chain rule to find the derivative. We're going to use the chain rule multiple times and use the chain rule with products and quotients to find the derivative, and we're going to find higher order derivatives using the chain rule. So let's first define what the chain rule is. Using this theorem, suppose y equals f of x is differentiable at u equals g of x, and u equals g of x is differentiable at x. The composite function y equals f of g of x, which is the same thing as y equals f of u. Is differentiable at x, and the derivative is expressed as follows. Dy dx is equal to dy du times du dx. So another way to write that is y prime is equal to f prime of u times u prime, like that. And that's going to be the way that I'm going to write it most of the time here. So this is the outer function. You take the derivative of the outer function with respect to u, and then take the derivative of u with respect to x and multiply them. All right, let's go ahead and if we have compositions of functions like this, take the derivative of the outermost function, leave the inner functions alone, then take the derivative of the next innermost function and keep multiplying until you run out of functions like that. Let's see here. Just as a review, with function composition, let's identify the inner and outer functions for the following function, f of g of x. So then differentiate these. So f of g of x is going to be f of x plus 1 squared. And I'm going to let f of x be equal to x squared as the outer function. G of x is equal to x plus 1. F prime of x is equal to 2x. G prime of x is equal to 1. And y prime is going to be equal to 2x times x plus 1 plus 1 times x squared is 2x squared plus 2x plus x squared is 3x squared plus 2x. Two x squared sorry, this is where there's an x here. I want f prime of g of x. So this is 2 times x plus 1, like that. And then times this. That's what I want. Okay, I'm used to writing this different, so sorry for, we're going to have to do f and g for a second, but the notation that I'm used to, I'll show you how I would do this. I would just identify inner and outer function. I'll just keep doing these this way. So inner function I'm going to call u is x plus 1. U prime is equal to 1. Y prime is going to be 2 times, let's just write y as u squared. So y is equal to 2u times u prime. 2 times u times u prime is 2x plus 2. There we go. This is 3x plus 1 to the 1/2 power. So y prime is going to be take the derivative of the outer function, leaving the inner function alone, times the derivative of the inner function. It's 3 over 2 root 3x plus 1. This is really the same thing as sine x quantity squared. Let's take the derivative of the outer function, leaving the inner function alone, times the derivative of the inner function. It's 2 sine x cosine x, which is the same thing as sine of 2x by identity. Now we're going to take the derivative of the outer function, leaving the inner function alone, times the derivative of the inner function. It's going to be a negative 9 sine of 9x. Same thing here, derivative of the outer function, leaving the inner function alone, times derivative of the inner function. It's going to be 15 halves, 5x plus 4 to the 1/2. That'd be the same thing as 15 root 5x plus 4 over 2. Take the derivative of the outer function. Leaving the inner function alone, times the derivative of the inner function. That's really as much as I need to do on that one. Now we have our u is equal to negative 4x. This is e to the u. So u prime is going to be a negative 4. If y is equal to e to the u, y prime is equal to e to the u times du dx. So y prime is going to be e to the negative 4x times negative 4, or negative 4 e to the negative 4x. This is the same thing as sine of x raised to the 3rd power. So y prime is going to be 3 sine squared of x times the derivative of sine is cosine. Now we have y prime equals derivative of the outer function. Leave the inner function alone. Times the derivative of the inner function. Like that. We're going to take derivative of the outer function. Leaving the inner function alone, times the derivative of the inner function. Like so. Now when we combine derivative rules, we're going to just generalize these rules. Again, I do so with u's and v's, that the derivative of product rule u times v equal to u prime v plus v prime u. Quotient rule, u over v, where u and v are functions of x, is u prime v minus v prime u all over v squared. And the chain rule here, I've already given it to you with u, that if I have the derivative with respect to x of f of u, it's going to be f prime of u times u prime. Let's look at an advanced example here. We're going to take the derivative of the outermost function. leaving the inner function alone, times the derivative of the inner function, which is going to require the quotient rule. Now this is going to be derivative of the top times the bottom minus derivative of the bottom times the top all over the bottom squared. This is squared here. This is going to be fourth power. This is squared. And this is going to be, let's take a 10x out. Squared plus 2 minus 3x squared. So that's going to give me y prime equals 3 times 25x to the fourth times a 20x over 3x squared plus 2 to the fourth. That's going to give me 75 times 20. It's 1500 x to the fifth over 3x squared plus 2 to the fourth. Yep. Okay. And let's move on to this problem. If u is equal to x squared and v is equal to x minus 1 to the 1/2 power, y is equal to u times v, y prime is going to be u prime v plus v prime u. U prime is 2x, v prime is 1 over 2 root x minus 1. The derivative of the inside there is just 1. So y prime is going to be u prime times v minus v prime times u. And sorry, this is plus, not minus. This is y prime is going to be, factor out that 1/2, factor out the x minus 1 to the negative 1/2, and factor out the x. It's common. 2 divided by 1/2 is 4. X divided by x is 1. X minus 1 to the 1/2 divided by x minus 1 to the negative 1/2. It's x minus 1 to the first. Plus 1/2 divided by 1/2 is 1. X minus 1 to the negative 1/2 divided by x minus 1 to the negative 1/2 is 1. X squared divided by x is x. So y prime is x. This is 2 root x minus 1. And this is 4x minus 4 plus x. So y prime is x times 5x minus 4 over 2 root x minus 1. It's the same thing as 5x squared minus 4x over 2 root x minus 1. All right. I'm going to finish up here by just some review of some important skills when it comes to rational exponents, fractional exponents. Remember how to add fractions. When you multiply like bases, you're going to add the exponents. If the exponents are fractions, you're going to need to make a common denominator to add them. So that's 2/6 plus 3/6 is 5/6. Also, we're going to need to rationalize denominators sometimes. So adding fractions. Rationalizing denominators. If I had 5x squared minus 4x over 2 root x minus 1, like from the last problem, I'd need to multiply by root x minus 1 over root x minus 1. And that's going to give me 5x squared minus 4x times root x minus 1 over 2 times x minus 1. And that's the same thing as 5x squared root x minus 1 minus 4x root x minus 1 over 2x minus 2. All right, that's it for this video, and we'll come back next time, and we will talk about the derivative of logarithmic and exponential functions. See you for the next video.